Sustainable design and green infrastructure. With a growing focus on environmental sustainability, civil engineers are increasingly incorporating sustainable design principles into infrastructure projects. This includes designing energy-efficient buildings, implementing green infrastructure solutions, such as green roofs and permeable pavements, and utilizing renewable materials. Certainly, sustainable design and green infrastructure have become crucial considerations in civil engineering to minimize the environmental impact of infrastructure projects and promote long-term sustainability. Here are some key aspects. 1. Energy-efficient buildings. Civil engineers incorporate energy-efficient design principles to reduce energy consumption in buildings. This includes optimizing insulation, utilizing natural lighting and ventilation, employing energy-efficient HVAC systems, and integrating renewable energy sources like solar panels or geothermal systems. 2. With green roofs. Green roofs involve planting vegetation on the rooftops of buildings, providing several environmental benefits. They improve thermal insulation, reducing the energy needed for heating and cooling. They also absorb rainwater, reducing stormwater runoff and alleviating pressure on drainage systems. Furthermore, green roofs contribute to urban biodiversity and can enhance the aesthetics of the built environment. 3. Permeable pavements. Traditional impermeable pavements contribute to stormwater runoff and water pollution. Permeable pavements, on the other hand, allow water to infiltrate through the surface, promoting groundwater recharge and reducing the strain on stormwater systems. They can be made of porous materials or incorporate void spaces to facilitate water infiltration. Utilizing renewable materials, civil engineers are exploring the use of renewable and sustainable materials in construction projects. This includes incorporating recycled materials, such as recycled concrete aggregate or reclaimed wood. Additionally, engineers are researching and developing new materials that have a reduced environmental footprint, such as bio-based composites or engineered timber. Water management and conservation. Sustainable design considers water management strategies to minimize water consumption and promote efficient water use. This includes implementing rainwater harvesting systems, using water-efficient fixtures and appliances, and designing landscape irrigation systems that utilize recycled or treated water. Life cycle assessment. Civil engineers perform life cycle assessments, LCA, to evaluate the environmental impact of infrastructure projects throughout their entire life cycle. LCAs consider factors such as raw material extraction, manufacturing, construction, operation, and end-of-life disposal. This assessment helps identify opportunities to reduce environmental impact and make informed design decisions. Sustainable transportation. Civil engineers play a role in developing sustainable transportation systems. This includes designing and promoting public transportation networks, incorporating cycling and pedestrian infrastructure, and encouraging the use of electric vehicles by providing charging infrastructure. By integrating these sustainable design principles, civil engineers aim to reduce energy consumption, minimize waste generation, conserve natural resources, mitigate climate change impacts, and create more resilient and environmentally friendly infrastructure. Certainly. Here are some additional details on sustainable design and green infrastructure in civil engineering. Passive design strategies. Civil engineers employ passive design strategies to optimize the natural elements of a building's surroundings. This involves harnessing natural light, maximizing daylighting, and utilizing shading devices to reduce the need for artificial lighting and cooling. Passive solar design techniques, such as building orientation and the use of thermal mass, can also help regulate indoor temperatures and reduce heating and cooling requirements. Net zero and energy-positive buildings. Net zero energy buildings aim to produce as much energy as they consume over the course of a year. These buildings incorporate energy-efficient design, on-site renewable energy generation, such as solar panels or wind turbines, and energy storage systems. In some cases, buildings can even generate surplus energy and become energy positive, feeding excess energy back into the grid. Green infrastructure for stormwater management. Green infrastructure solutions, such as rain gardens, bioswales, and constructed wetlands, are designed to manage stormwater runoff naturally. These features capture and infiltrate rainwater, filtering out pollutants and reducing the strain on traditional stormwater systems. Green infrastructure also helps replenish groundwater, reduce the risk of flooding, and enhance water quality. Urban heat island mitigation. Urban areas tend to have higher temperatures than surrounding rural areas due to the urban heat island effect. Civil engineers implement strategies to mitigate this effect, such as designing green spaces and urban parks, increasing vegetation cover, and utilizing cool materials for pavements and rooftops. These measures help reduce the heat island effect, enhance thermal comfort, and lower energy demands for cooling. Circular economy principles. Civil engineers are increasingly adopting circular economy principles in construction and infrastructure projects. This involves minimizing waste generation, promoting recycling and reuse of materials, and designing for disassembly and future adaptability. By implementing circular economy practices, civil engineers aim to reduce resource consumption and minimize the environmental impact associated with construction and demolition activities. Resilient and adaptable design. In the face of climate change and evolving environmental conditions, civil engineers are incorporating resilience and adaptability into their designs. This includes considering potential future scenarios, such as sea level rise or extreme weather events, and designing infrastructure that can withstand and recover from these challenges. Flexible design approaches and adaptive strategies can help ensure the longevity and functionality of infrastructure in a changing climate. Public awareness and education. Civil engineers play a role in raising public awareness about the importance of sustainable design and green infrastructure. They contribute to educational initiatives, community outreach programs, and public engagement efforts to promote understanding and support for sustainable practices. By involving the public in decision-making processes, civil engineers can help foster a culture of sustainability and encourage the adoption of green infrastructure solutions at a broader scale. These are just some of the many aspects and considerations within sustainable design and green infrastructure in civil engineering. The field is constantly evolving as new technologies, materials, and practices emerge, aiming to create a healthier, more resilient, and sustainable built environment. Certainly, civil engineers can incorporate circular economy principles in construction projects in several ways. Here are some examples. Material selection and reuse. Civil engineers can prioritize the use of materials with a lower environmental impact, such as recycled or reclaimed materials. They can source construction materials from demolished structures or other industries, promoting their reuse and reducing the demand for virgin materials. Examples include using reclaimed timber for structural elements or incorporating recycled concrete aggregate in new concrete mixes. Design for disassembly and adaptability. Civil engineers can design structures with disassembly and adaptability in mind. This involves considering how different components can be easily separated and reused or recycled at the end of a structure's life. Designing modular systems that allow for easy replacement or expansion without significant demolition can also promote adaptability and reduce waste. Construction waste management. Civil engineers play a crucial role in managing construction waste. They can implement strategies to minimize waste generation, such as optimizing material cutting and sizing to reduce offcuts. Additionally, they can establish waste segregation and recycling practices on construction sites, ensuring that materials like concrete, metal, and wood are appropriately sorted and sent for recycling rather than being disposed of in landfills. Construction and demolition waste recycling. Civil engineers can promote the recycling of construction and demolition waste by collaborating with recycling facilities and incorporating recycled materials into new projects. For example, crushed concrete can be used as aggregate in new concrete mixes, or recycled steel can be utilized in reinforcing structures. By closing the loop and reusing these materials, civil engineers can reduce the demand for extraction of virgin resources. Life cycle assessment. LCA civil engineers can conduct life cycle assessments to evaluate the environmental impact of construction projects from cradle to grave. By considering the entire life cycle, including material extraction, manufacturing, construction, operation, and end-of-life disposal, engineers can identify opportunities for reducing environmental impacts and make informed decisions regarding material choices, design strategies, and construction methods. Collaboration and stakeholder engagement. Circular economy principles often require collaboration among various stakeholders, including designers, contractors, suppliers, and waste management providers. Civil engineers can facilitate this collaboration by engaging with stakeholders throughout the project lifecycle and promoting the adoption of circular economy practices. By involving stakeholders in discussions and decision-making processes, engineers can create a more circular and sustainable construction industry. It's important to note that the implementation of circular economy principles in construction projects often requires a holistic and collaborative approach. Civil engineers need to work closely with architects, contractors, suppliers, and other professionals in the construction industry to ensure the effective integration of circular economy principles throughout the project lifecycle.